All right, in this video, we're going to do another gravimetric stoichiometry problem, basically a mass-to-mass problem. So let's do example 6 from your handout. Determine the amount of ammonia produced when 3.5 grams of nitrogen reacts with excess hydrogen. So let's write out a reaction first, an equation first, because I think we're always stuck unless we can visually see what's happening. Hopefully I made enough room. I don't think I did, but we'll make some room if needed. So the amount of ammonia when nitrogen reacts with hydrogen to make ammonia. Okay, so nitrogen, don't forget, is diatomic. That's a gas. Plus hydrogen, which is also diatomic, which is a gas. Producing ammonia, which is NH3, a gas as well. And we need to balance it first. So that's our first step. Make sure we have a balanced equation. So I'll put a 2 here, a 3 here, and a 1 here. So we're good. And let's put some information down. So we have the mass of nitrogen is mass is equal to 3.5 grams. And we want to find the amount of ammonia. It's a bit ambiguous, that wording. Let's just say we mean mass here. Let's just say we mean mass. So we want to find the mass of ammonia. To do that, you need the number of moles of ammonia times the molar mass of ammonia. So we have information about nitrogen, but it's only mass information. We can't do a mass to mass ratio. And so what we can do, though, is we can do a mole to mole ratio by converting the mass of nitrogen gas into the moles of nitrogen gas. So let's go ahead and do that. So let's do that. The moles of nitrogen gas are going to be equal to the mass of nitrogen gas over the molar mass of nitrogen gas. And again, notice I'm putting nitrogen gas next to all the little variables there because we have to use these equations a few times for different substances. I don't want to confuse where my steps are for different parts. So here I have 3.5 grams over the molar mass of nitrogen gas, which is 14.01 times 2 because it's N2, right? So that would be 28.02 grams per mole. Cross grams out, and we get, so 3.5 divided by 28.02, and we get this value here. So 0.124910778 moles. In our step 3, we can make a mole ratio between the nitrogen and the ammonia because those are the two we're comparing. So we can say it's a 1 moles or molecule of N2 for every 2 moles or molecules of NH3. So now that you see that, you know it's a simple multiplication by 2. So in your head, you can figure that out. But let's show you all the work that we need to do that. We can also write it as a fraction form. So we can do 1N2 over 2 NH3. Or we could write for every 2 NH3, there is 1 and 2 that way. And we choose which fraction to use in our dimensional analysis. So step 3, we're going to take our moles of N2, so 0.124910778 moles of N2, and we're going to multiply it by the conversion factor that gets rid of N2, which would be this one over here, because N2 is at the bottom. So 2 moles of NH3 over 1 mole of N2. Moles of N2 cancel out, and we're just doing our moles that we got for N2 multiplied by 2. So times 2, and we get 0.2498 21556 moles of NH3 produced. We're almost done. We just need to now convert this into mass because we have the number of moles of NH3 now, and now we just need to multiply by the molar mass to find the mass of NH3 because it's what we're looking for based on the question. So if it was a regular mole problem, we could just do mole to mole, but since it was mass, we had to find mole, then use that mole to find the other mole, and then convert back to mass. So our step 4 is converting back to mass. So we're going to have our mass of NH3 is equal to the moles of NH3 multiplied by the molar mass of NH3, which is just going to be the moles that we got there. So 0.249821556 moles multiplied by the molar mass of NH3. So the molar mass of NH3 would be 14.01 plus 3.03. So that would be 17.04 grams per mole. And then moles cancel out, and you get grams left over. So we get about 4.256959315 grams of NH3, which is approximately, according to sig figs, we have 2 sig figs here. So we have 4 point, we want to keep it to here. We have 5 there. Normally we'd round down to 2 because it's even, but notice it's 5 and a whole bunch of decimals after, so we can go up. So 4.3 grams. And so our step 5 is simply, therefore, approximately 4.3 grams of NH3 are produced. So again, this was based on sig figs. There's 2 sig figs in this question. If there's several numbers given, you'd have to choose the smallest number of sig figs. But in this case, it's only the 2 there. And remember, we don't count the molar masses in our sig figs. We don't count the coefficients in our sig figs either because they're not measured values. And I did mention in other videos, sometimes we don't want to use sig figs because they might not be measured values throughout, but just continue using sig figs to keep it consistent unless I tell you not to use sig figs. In our next example, we're going to do example 7, which is very similar to example 6. It's essentially the same pattern every time. If you don't have moles, convert to moles using your molar masses, and then use your mole ratios to find the mole, and then convert to whatever you want at the end there. So example 7 will be done in the next video.